Next is question number 59, which says that is a column matrix match question. So let us solve it option by option. Let's go by option A first, which says that slope of common normal to the curves y square equal to 4x and x square plus y square minus 6x minus 1 equal to 0 is. So the equation of circle can be written as x minus 3 whole square plus y square minus 10 equal to 0. So that is equal to 10. Now the common normal will pass through the center of the circle, that is it will pass through 3, 0. Now the general equation of normal for parabola is y equal to mx minus 2am. A here is 1, so we'll write minus 2m minus m cube. This is the equation. As it is passing through 3, 0, so it will be 0 equal to 3m minus 2m minus m cube, that is m minus m cube equal to 0, which means that m is either equal to 0 or 1 or minus 1. So from the given options, Q, R and S will be the correct answer. Now option number B says that slope of common normal to the circles. Two equations of circles are given. We know that normal will pass through the centers of both the circles. So we can directly write the equation of normal by finding the center of both the circles. Now center of first circle is 1, 3, that is dividing the coefficient of x and y respectively by minus 2, and the center of second circle is 2, 1. Now the slope of the common normal can directly be found. Slope will be equal to 3 minus 1, that is 2, upon 1 minus 2, that is minus 1. So the slope is minus 2, that is option number P is correct. Now option number C says that slope of tangent drawn from the point 5 by 2, 0 to the ellipse x square upon 4 plus y square upon 9 equal to 1 can be. Now slope of tangent on ellipses y equal to mx, as the major axis of the ellipse is along y-axis, so it will be y equal to mx plus minus under root of 4m square plus 9. As it have been given that the equation of this tangent is passing through 5 by 2, 0, so let us satisfy that point. So we'll get 0 equal to 5 by 2m plus minus under root of 4m square plus 9. That is 25 upon 4m square is equal to 4m square plus 9. Taking 4m square on the left hand side, we will get 9m square upon 4 is equal to 9, that is m is equal to plus minus 2. So from the given options we can see that P and T are satisfying it. Now let's move on to option number D, which says that slope of normal to the rectangular hyperbola xy equal to 4 can be. Let us take any point on it, that is 2t, 2 upon t. Now let us differentiate the hyperbola, that is x into y dash plus y is equal to 0, that is the value of y dash is equal to minus y upon x. So this is the equation of the tangent. So slope of normal will be equal to x upon y, that is equal to x coordinate is 2t upon y coordinate is 2 upon t, that is equal to t square. Now here it can be seen that t square is always greater than 0 because t cannot take the value 0 because here the point is in denominator. So t square is always greater than 0, which means that only positive values can be taken by the slope. So from the given options it can be seen that S and T will be the correct answer. Next, now the last question is question number 60. That is, consider a system of equations ax square plus y square equal to 1. Similarly, two other equations are given where it has been given that a comma b belong to minus 2, minus 1, 0, 1 and 2. Let lambda be the number of ordered pairs a comma b corresponding to event E, where events E are given in 4 options in the column. Now, so let us solve the question. Option number A says that E be the event that the system of equations has infinitely many solutions. Now, for this, firstly we have to find the value of delta 1, delta 2 and delta 3. So let us start the question. Value of delta will be equal to Here we are assuming the system of equations in x square, y square and z square, right? So delta will be a 1 0 1 minus 1 1 a 1 b. So solving this, we will get delta equal to minus b into a plus 1. Similarly, let's find the value of delta 1, that will be equal to minus b into 1 plus b. Similarly, we will find the value of delta 2 and delta 3, that will be equal to b times ab minus 1, and when we will find the value of delta 3, it will come out to be equal to 0. These can be found out very easily. Now next, option number A says that let E be the event that the system of equations has infinitely many solutions. For infinitely many solutions, we know that all the deltas should be equal to 0, right? Now, for delta equal to 0, we have two cases, that is either A is equal to minus 1 or B is equal to 0, right? Now, if A is equal to minus 1, then in delta 2 we will get B times B plus 1. Now, for A equal to minus 1, for all deltas to be equal to 0, we have to put B equal to either minus 1 or 0, right? When we take A equal to minus 1, then we have to take B equal to either minus 1 or 0. Only then we will obtain infinitely many solutions. Now, for B equal to 0, it can be seen that they are always 0. So, the number of ordered pairs A, B are, and we will get 5 ordered pairs from here, from which one will be intersecting in both. So, we can say that in total there will be 6 ordered pairs. So, the value of lambda will be equal to 6, which means that option number T is correct. Now, next, option number B says that E be the event that system of equations has finitely many solutions. Now, as we are solving the equation, taking x square, y square and z square, so if I apply for unique solution, then we will get finitely many solutions in this case. So, we know that unique solution, delta should not be equal to 0, right? That is, B should not be equal to 0 and A should not be equal to minus 1, right? B should not be equal to 0 and A should not be equal to minus 1. So, the number of ordered pairs A, B that can be formed are, for A we have 4 possibilities and for B also we have 4 possibilities. So, in total we will have 16 such systems, right? So, the value of lambda will be equal to 16. So, we can say that option number T is the correct answer. Here we got lambda equal to 6 and here we got lambda equal to 16. Now, next is option number C, which says that let E be the event that system of equations has a unique solutions. Is it possible for x square, y square, z square to have a unique solutions? No, they can never have unique solutions, which means that lambda will be equal to 0. That is, answer is P. Now, next is option number D, which says that if E be the event that system of equations has no solution. Now, for no solution, we know that delta should be equal to 0 and at least one delta I should not be 0, right? Now, delta is equal to 0 for A equal to minus 1 or B equal to 0. In these two conditions only we will get delta equal to 0. Now, if I take B equal to 0, then all the delta I's will be equal to 0. That is, it will never give me no solution. So, this is not the case. Now, if I take A equal to minus 1, then delta will be 0 and delta 2 will be equal to B plus 1. That is, for no solution, we have to put B should not be equal to 0 or minus 1. Right? So, how many ordered pairs A, B we will have? A is fixed, that is minus 1, that is we have only one possibilities, and B should not take the values 0, minus 1, that is B can take 3 values. So, in total we will have 3 ordered pairs, that is value of lambda is equal to 3, that is lambda is a prime number, Q, R and S. This will be the answer. I hope the paper that have been just discussed is clear to you. Now we will solve test 6A paper 2. Thank you for watching.